All right, well, let's start working with these data on the computer. You'll see here I have a Labradar folder that I made, and if I go into this, I have quite a number of different series, 6 in fact, that were recorded when I was out at the range just not too long ago. And this is the Excel file that I'll be sharing with all of you if you're interested in using this. So let me go into one of these series. Let's go into series 225. And you're probably very familiar with this file right here. It's pretty much your summary file. And what we see here is this is a CSV file, by the way. That is a comma-separated values file. If I double-click the edge of the A column over here, it just expands it to the larger size so I can read everything. There's my average, high, low, extreme spread, and standard deviation. Just a terrible standard deviation, by the way. If you saw some of our past videos, you might actually recall me commenting about the same thing. And in this particular series, 4 of the 5 shots were recorded. I'm going to close this. And actually, the files I'm most interested in today are these track files. There's a track for each individual shot. And as we can see, again, we have 4 shots we know were recorded in that summary file, and we have 4 separate shot tracks in this particular folder. This shot was tracked out to 28 yards. And you'll notice that there are 4 separate fields or columns to each of these track CSV files. First is the time, and we're not going to make any use of the time field. Second, though, is the velocity, and the first, of course, is your muzzle velocity. Then we have the distance, and of course the muzzle velocity is at a distance of 0, and signal to noise ratio is not applicable at this point. But this SNR, signal to noise ratio, is very important. And what we like to do is we like to make sure that we are working with records or rows of data that always exceed 12, a signal to noise ratio of 12. And the higher the number, the better. So we want to have lots of signal, very little noise. This one right here, recorded at 17.62 yards, is problematic. But notice we don't have to discard everything after it, because the follow-up shot, or the follow-up record at 18 yards had a signal to noise ratio that exceeded 12. And so that's a good one. Another good one, but now a bad one. And what I've noticed is that you start having more and more bad signal to noise ratios, obviously, as that shot or that bullet travels further and further downrange. So just be aware of that. We are going to get rid of the bad data that have low signal to noise ratio later. The other thing I wanted to point out is that if you know you were shooting at a target at 100 yards and suddenly you're seeing the projectile tracked at 120, 125, whatever it happens to be, yards, discard those also, because what you're looking at is probably actually the bullet was still traveling through that target. Maybe it tracked a ricochet, or it simply had an error in the tracking. So if you know you were shooting at a target out at 100 yards, then certainly don't include any data collected after that target distance. Okay, so what I'm going to do now is I am going to be working with all of this data right here. I'll just kind of select it for the time being. Now I'm going to go back to my file manager and go back up to my Labradar folder, and this is the XLS file that I'm going to be using today, and this is actually the one that I'm going to be sharing with you if you want to make use of it. So let me go ahead and open this up. This is an actual Excel file. And all of these data that I'm going to be talking about today, and all the calculations, I should say, that I'm going to be talking about today are derived from this equation here. And certainly take a look at the links where this stuff all came from. This part of the table up here was just more or less a proof of concept when I was calculating through some stuff to make sure everything worked. And you'll want to make note of this. Do not enter values into any of the shaded cells. Okay, those are values that are calculations that are correct, so don't be changing those things. If you happen to accidentally change those things and you've already saved the file, that's all right. Go ahead and grab another copy of it from the share link that I'm going to give you in the description for this video. Pay attention to this. Also, what I'm telling you to do here, actually reminding myself, is to copy and paste this table. It looks just like this. We already know about this from the Labradar Track CSV file. There'll be one track for each bullet and each round fired, and thus a lot of data to base a good ballistic coefficient estimate upon. And there's my reminder again, SNRs greater than or equal to 12.0. Now this whole process came up. You know, I did a video not too long ago that talked about really this same process, but I used the JBM Ballistics website to calculate those estimates one round at a time, or actually one observation at a time. And that became kind of tedious, especially when you're going to see we have hundreds of observations that we can use in that track file. So I thought there's got to be a better way of doing this, and so I decided to do some digging, find out how to do this sort of calculation, and then put it into an Excel spreadsheet to really automate the process. So you might remember, hey, we already saw data just like this. And it is in our track file. And I'm going to delete everything I have in here right now from a previous calculation. Just select it, press delete from the keyboard. Now I'm going to click in this upper left column right here, A17, upper left cell. I'm going to go back to Excel. I'm going to copy this again. You can also press Control C, go back to BC Calc, A17, right click, paste. I did paste values. You could have just done paste. You're going to see where paste values becomes kind of important shortly. I've used this first line right here to be an example line. Again, don't edit anything in these gray cells, no matter what shade of gray. But then what's happening is this is taking data that it finds over here, and it's doing all of the calculations necessary. You're going to find that your muzzle velocity is copied redundantly over and over and over again into the velocity at 0, muzzle velocity. The velocity 1, the second observation, is going to be changing, and then your calculated or estimated G1 ballistic coefficient is shown here. Now all of this work really came about because of my experiment, my nice test with the 168 grain Speer Gold Dot. And now those Speer Gold Dot bullets, they really did a beautiful job in my 308 Ruger precision rifle out to about 100 yards. A little bit past it, I think it did just fine. But then once I started shooting longer ranges, they didn't kind of do so well anymore. 200 yards in one instance, it just absolutely fell apart. In other instances, it just never beat the Sierra tipped Match King again. Now, one of the questions posted by one of the viewers was, what is the ballistic coefficient of that Speer Gold Dot? And the ballistic coefficient, that G1, that's posted by Speer is well over 0.5. And if you look at that little bullet, it's a short little bullet, kind of a stubby little bullet. Like I said, it did shoot very, very well at close range, and actually was very promising for me for quite a while. but it seemed kind of counterintuitive that that bullet would have such a very, very high ballistic coefficient. So you'll see what I have here. I have another tab in this spreadsheet, and I have every track for every bullet from various events when I was shooting. I have 672 observations. Now, the problem with this, though, is you'll notice that a lot of these observations, a good number of these observations, are well below 12. So we got to get rid of those. Remember that. And the other thing is the distance in yards is also, we got to make sure that it is not beyond the distance of the target. Some of these rounds were fired at 100 yards. Some of those were fired at 200 yards. So then I have another tab over here. It's called my Spear Clean Data. Again, I'm looking at my SNR. I kept the SNR. I kept the distance, and of course the resulting G1 ballistic coefficient. But every one of these has an SNR, signal to noise ratio, above 12, 12.0 and above, and the distance in yards is at the target or before the bullet struck the target. And I still have 365 observations. That's a lot of observations. Now, my mean ballistic coefficient is not 0.572 as reported on the Spear website, but rather 0.383. That's the mean or the average, and the median is 0.384, almost 0.385, with a very tight standard deviation. This is a little graph that I put together of the G1 ballistic coefficient where signal to noise ratio is greater than 12, and I'm actually plotting signal to noise ratio here and ballistic coefficient there. And as you can see, as we get close to 12, we start seeing more dispersion. And in fact, if a person wanted to, they could impose an even tighter threshold of maybe 15 or above, and that might further clean up the data. But the data is pretty tight. The data is pretty tight right now, especially in comparison to what it was, with a mean of 0.448 and a median of 0.394 when we had all 671. But look at the dispersion here in this graph, the same type of graph we looked at before. When we start getting values below 10, the dispersion is absolutely insane. In fact, sometimes the ballistic coefficient exceeds 1.0, and you gotta know that is flat out wrong. I did another graph over here that's also, I think, quite interesting, that shows the ballistic coefficient as a function of distance. And what we see is that after 100 yards, in many cases we shouldn't even have observations. Some cases we do, but for the most part, some of these over here are wrong. They shouldn't even exist. But look at the dispersion again in ballistic coefficient as that bullet travels further and further away from the lab radar. And remember, the lab radar, yes, it's sucking up the power. It's trying to track that bullet as far as it can, but because of quite a number of different reasons, and primarily the fact it's not too terribly expensive of a unit, and something that can track further than maybe 100 yards or so would probably run you into several thousands of dollars, and you might have to have a generator to keep it running. I don't know. But kind of interesting results there as well. Well, when I was working on this, I said, well, let's take a look at the Sierra tipped Match King, another 168 grain bullet. And it does have a much higher ballistic coefficient, but again, not as high as is reported by Sierra. And by the way, I always like to look at and compare the mean and median values. If they are different, quite different, and these are not, but if they're quite different, that tells us that we're not dealing with what's called a normal distribution of data. Don't worry about those statistical terms. What it's really telling us is that there's probably something odd about your data. And then maybe for this video, that's as far as we need to go. If we look at the spear gold dot results without, kind of being cleaned up, look at how different those values are. 0.448 versus 0.394, tremendously different. Another hint that there's something wrong with this data, and in this case, the problem with the data is you have these outliers that are not representative of good data. Very poor signal-to-noise ratios. The bullet was being tracked after it passed through the target, etc., etc. Now you might be asking, how do I get from this to all this? Well, let me show you those steps. First of all, let me delete the existing data. Again, I'm not going to get any of the data that is in these gray colored cells. I just selected those cells. Yes, now they look gray, but we know they're really not. I'll press delete from the keyboard, and that clears this up. Now again, I'm just going to put focus on cell A17. Now let me find a new shot track. And here's my Labradar folder that I copied across. I made a Labradar folder, and I copied an entire day's worth of series that I was shooting out at the range. And the one I'm going to take a look at here is this session 226. This was actually shot with my .308 Winchester 168 grain Sierra tipped Match Kings. I'm going to go into the track folder or subfolder. Let's take a look at this one right here. It was the track for shot number 2. Notice on this one, only 3 of the 5 rounds that I fired were actually recorded. Had a little bit of problems with the Labradar that day, not recording. I don't know what exactly was going on. But anyway, let's take a look at this. Now, what's interesting here is this target was set up at 100 yards. And yet, I have recordings or records well beyond 100 yards. So automatically, we know that there's some cleanup that needs to happen with this particular file. I'm not going to clean it up here. I'm simply going to copy starting at A5. I'm going to copy all of these, right click, copy. I'm now going to go back to my BC Calc Excel spreadsheet, right click in A17. I'm going to paste this in just like I showed before, and notice that immediately these cells are changing. They have updated. Again, this is still all good. I don't want to make any changes to any of this data at this point. What I'm going to do instead is I'm going to copy data again. I'm going to copy data again. I'm going to take this SNR column, so that's going to be at cell D17, delta 17. I'm going to scroll all the way down to the last good record, or the last record, I should say. We know that some of these are not good. I'm going to put my mouse cursor over H, in this case 103, the last good record, or the last record I have of data. Notice all of these have been selected. I'm not going to change any of this data in these gray cells, just selecting them. Copy those, and I'm going to go to a brand new spreadsheet tab. And in here, I'm going to right click on A1, and here's where we need to use this paste special values, or paste values. Because of the calculations that are done here, if I clicked paste, well, it's going to give me, I'll show you that. It's going to give me some errors, reference errors. Well, that's because it's looking for data here that I didn't copy all the way across. That's why we do the paste special as values. Now there's a couple things in here I don't need anymore, and that is the velocity columns, velocity at the muzzle, velocity 0, and velocity 1, C and D columns. I'm going to go ahead and delete those. I'm going to expand my B column just so I can read all that. Maybe you like to see this in bold so it reminds you that that is the column label. And now I need to clean this thing up. So this is still in the same shot order, or the same order as recorded by the lab radar. And if I scroll down, I know that my target was at 100 yards. It's possible that this is a good one, but I'm not going to trust it. So I'm going to select all of those, just like I've just done, and right-click, delete. Now those are gone. Now you'll also recall that we want to get rid of all of the records with SNR, signal to noise ratio, less than 12. But that number can appear, anywhere inside here. And it's going to be really, really slow to kind of you scroll through this thing and, gee, where is one of those? Here's a little trick, really easy to do. Just click somewhere inside this A column. Now look over here on the far right side of Excel, up on the ribbon, sort and filter. So click on this, and we want to tell it to sort. Let's do largest to smallest. That's just fine. Now we're not wrecking any of this data. Nothing is getting wrecked or destroyed or anything like this. We're simply resorting it, and everything resorted. Not just this column, but the entire record based on the sorting that I did on A. Now if I come to the top here, we see that our highest signal to noise ratio was 34.5, and it happened to be at that first observation at 12.7. That's normally where I'm getting my first observation, obviously past the muzzle itself. So let's scroll down here, and pretty soon we're going to get to the point where we have fallen below 12. Once again, select those records that we know are bad, right-click on that, delete, and now it is nice, clean data. A couple of other things that I like to do here is I don't need to see some of these additional decimal places, so I'm going to reduce the number of decimal places to 3. That will work out just fine. That was that button right over here, decrease decimal. Just to the left of it is increase the decimal if you want to do that. And now how do we do the graphing? Let's look at the graphing. Okay, so let's say I want to graph the ballistic coefficient by distance. I'm going to go ahead and select these two right here, just the data. Now we click Insert from the menu. I'm going to come over here to my charts, and this is the Insert Scattered Chart XY. So we have an X, which is distance, and a Y is going to be our ballistic coefficient. And by the way, if you're using a slightly different version of Excel, these ribbons and stuff might look a little bit differently, but Excel has had these same tools available to it for years, so you'll be able to find this thing. And there is our G1 ballistic coefficient on the y-axis by distance. And you can change the chart title, if you like, to by distance. There we go. Now, if you've been watching some of our other extreme reloading videos, you'll notice a lot of times I talk about the R² value and the linear trend of a certain set of data. Well, we can do that. I'll just show you how to do that. I don't know that it's too important in this case, but it might be kind of interesting. I'm kind of interested in this one way out here. We have a big jump, don't we, between about 80 yards observation or measurement there but then all of a sudden we lose about 20 yards. So let's just see what's happening here. I have selected that set of data, and now I'm going to click on, I right-clicked on it, and now I'm going to click or choose Add a Trend Line. That brings up this pane along the right side. Linear type of trend line or linear relationship is what is defaulted. And now I'm just going to turn on two things: display the equation and display the r-squared value. You can now see that the r-squared is actually poor. It's only a 12%, effectively 12% of the variability we see in ballistic coefficient can be explained by the distance of that projectile's measurement from the muzzle. Like I said, I don't know that it's too important really to do that, but I simply wanted to show you how to do that. Now, the other thing that's important is we ran some descriptive statistics. And to do that, I need to click on the Data menu, and then on the far right side, at least on my computer, is the Data Analysis Tools. By the way, if you don't have or don't see the Data Analysis Tools, come over here, back onto the menu, to the File, and then on my computer, again, all the way to the bottom is Options. Now I've clicked on Add-ins, and I need to select, find and select. This is a default tool pack. You should always have it available to you. Click the Analysis tool pack and then click OK. I've already got it loaded, so I don't need to click OK. I'm just going to click Cancel. Now with Data Analysis available to me, I'm going to click Data Analysis. That brings up a whole suite of different statistical tools I can use, and the one that I want to use is just to see the descriptive statistics. Select it, click OK, and this little dialog box pops up. It says, what's your input range? Oh, that's easy. Click on this to make my selection. Notice it kind of rolls up and gets out of your way. I'm going to select this top one, scroll down, press and hold the Shift key on my keyboard, click the bottom one. Notice the entire selection has been made. Come back over here, and this is more or less an enter or accept this. We go back to this dialog window, tell it that labels are in the first row, okay, because I did include G1BC as or in my selection input range. Organized in columns, obviously, it figured that out for us. Now I'm going to change the output range, I should say, change the output range. Again, using my little selector, and I'll click here, just in one spot, one cell, which will hold, it'll be the anchor point for the upper left part of the little table it's going to write for us. Now what do we want? Let's keep working on this thing. Working down here, I want to see summary statistics. That's all I'm interested in. Click OK. There we have it. Normally, I will expand this so I can read these titles here, and we see that the mean ballistic coefficient is 506, the median is 513, and you know, that's not too bad. We do have already 61 samples, but if I wanted to, and I've already done this for my Sierra Tip Match King, what I call clean data, I ended up getting 376 good observations, and 61 of those are from this right here. So that is a very, very simple process where you can obtain literally hundreds of samples of ballistic coefficient out of your rifle with your particular bullet of choice, and then you can, you know, utilize that improved ballistic coefficient to calculate your drop tables. Well, I hope you enjoyed this video. Thanks a bunch for watching. If you have any questions, go ahead and post them in the description below.